Hello everyone, welcome to the next lecture on the probability and statistics. Today we will discuss about what is the two-factor factorial experiment. Myself, Dr. Garg, working in the School of Mathematics, Thapar Institute. So before we start with the what is the factorial experiment, let me tell you a simple example. Suppose you are the chemical engineer and you are try to investigate the effect of the reaction times on the reaction temperatures and on the process of the yield. So how you can do that? So whenever you are thinking on the process reaction time, say you consider the reaction time as 1 and 1.5 hours and the reaction temperatures at 125 degree Fahrenheit and then so on. So how you do that? So you can consider as a 1 hour, and after this 1 hour you can check the components at the 125 degree and at say 150. Similarly for the 1.5 hours and so on. So how many levels are there? Corresponding to this experiment you will get some reading x11, corresponding to 1 hour and 150 you will get the another reading and so on. So you will get the 4 different readings are there. So this kind of the experiment is called as the factorial experiment. So factorial experiment consists of the making experiment runs at each of the 4 possible combinations of this one. Or in general, but you can say that whenever there are the several factors associated with your experiments, then the factorial experiment design always be used. Or in general, factorial experiment design, that is that each of the experiments are performed at all the combinations. So let's say we can expand this 2 case into here. Suppose you have the 2 factors A and B, and this factor A is basically divided into the A low and A high, similarly for the B low and B high. And these are some random readings are there, 10, 20, 30, 40. Then your target is to analyze the effect of the A. Similarly, you can analyze the effect of the B. How you can analyze the impact of the A? So the main effect of the factor A is nothing but the difference, average difference of the high level minus low level. So what is the average of this? 30 plus 40 by 2 minus of the low level, it will be the 20. So since this is a positive sign, so what is the meaning of the positive sign? It means whenever you increase the level of A from low to high, there is a changing which is increases by 20 units. Similarly, you can find the factors for the B. That is the main effect for the B is high, average of this minus average of this, that is average of here. Again, you can see this is the positive sign, plus of 10. So it means whenever you increase them from the low to high, the impact will be increases. But however, it is not always true that whenever A is increases, B is also increases. So you can say there are the several experiments in which the difference of the responses are not the same at all the levels. Whenever there is a change in the level, we will call as the interaction level between them or the interaction factor between them. How you compute the interaction factor? We will denote it as the AB, that is the interaction factor between the AB, which is defined as the difference in the diagonal average. So what is the average diagonal entries of the high? These are the average value of the high. So this is 30 plus 20 divided by 2, this is the average, minus 10 plus 40, that is a low R there. So once it's a 0, what is the meaning of that? There is no interaction factor between them. We can see that, we already see that A is increases, here B is also increases, that's why there is no interaction level. However, if you change the example, like here, if I change them to be a 0, then you can see AB is a non-zero, that's a 20. So what is the meaning of that? Their interaction level is very high. Why? You can see what is the main impact of the A. So you can compute them 30 plus 0 by 2 minus of here, that is 30 by 2. You can see it's a 0. Similarly, if you want to find the impact of the B, so it will be 20 divided by 2 minus of 40 divided by 2. It's here. So that's why you can see there is a change of the 20R. Or another way you can draw it graphically. You can see corresponding to this is the 10 and 20. This is the value of the 10 for the A low. This is the value of the 20. And this is the A high. This is a 30 and 40. You can see these lines are my parallel. So there is no intersection points are there. So once there is no intersection point, it means there is no intersection are there. On the other hand, when you consider about here, this is the 10 and this is my 20 corresponding to the first line, and this is for the A high, this is my 30 and this is my 0. You can see there is there is a point of intersection between them. So we can say factorial experiment with the interaction. So this is a simple example for that. Now we can generalize them to be the here. So we will consider the two-factor factorial experiment. Say there are the two levels, two factors A and B, and factor A has A elements, B has the B elements, and each of the element consists of the n replicates are there. While when we studied the one-way and the two-way ANOVA, one-way and two-way ANOVA, it consists of only one element, that is x11. But here it consists of the n number of the elements. Same for here. What is the meaning of this? Means there is a first row, first column, and the second element. What is the meaning of this? Is first row, second column, second element, and then so on. So how many elements are there? Total observations are AB. Each of the elements has n, so the total number of the observations are A, B, n are there. Once we will get this A, B, n, then we can define the statistical model of this according to the ANOVA model, that is the mu. What is the mu? Is that is a overall mean. How you can find the overall mean is you can take the sum of all these observations, say xij, divided by the total number of the observations. What is the tau? This is the main effect of the factor level A or the factor A. This beta is the factor effect of the B. Tau beta, that is the AB, combination of the A, that is the interaction factor are there. And epsilon is nothing but the random error. Once you are defining these all factors, then our target is to check the testing of the hypothesis. Also we will do like ANOVA for the effects on the A, that is there any difference between the A1, 2 and A? Is there any difference between the 1, 2 and B? And is there any difference between their interactions? So we will perform this 3 times ANOVA. What will happen if you consider the statistical effect of the fixed effect? Once we are taking the fixed effect, what is the definition of the fixed effect is? That is, you have to take the deviation from the mean. Once you take the deviation of the mean, so it means this all the factors are my 0. Total deviation is my 0. And we will use the analysis of the variance ANOVA to test the main factors of the A, B and AB interaction. That is, we will apply the main ANOVA on the here, ANOVA on here and ANOVA on here. How you can do that? Our target is to find the ANOVA. For this we have to define the H0 and H1, that is null hypothesis and the alternative hypothesis. This is for the A, called as the tau 1 to the tau A, all are same and at least one of them differ. Same for the factor B, same for the no interaction, that is the tau 1, 1, 1, 2 up to the AB are 0. Once we are defining the null hypothesis, our target is to define the ANOVA table. And how you can compute the mean sum of means square is, that is whatever the answer of this divided by A minus B and so on. We will explain this with the help of the couple of the examples. 3 to 4 examples are there. How you define the value of the SSA, SSB and so on, we will see here. So right now it's very difficult to remember all these formulas, but we will see in a couple of the examples. So we will see the 3 examples. Is a very simple, you can simply learn from them. Say the aircraft primer paints are applied to the aluminium surface by the 2 methods, dipping and spray. The purpose is to improve the paint's adhesive, and some results are there. You have to check whether there is any interaction between the primer types and the method of the dipping, or there is any difference between the primer types and the methods are there. Now you can see there is more than one elements appear here. It means the one-way ANOVA and the two-way ANOVA is not applicable here. What you can do is you have to firstly define the define the hypothesis. One is corresponding to the primer, second is corresponding to the method, third one is the interaction. How many primers are there? There are the 3, so we consider that mu1, mu2 and mu3 all are same, and at least one of the mu I is not 0. Same for here, this is the dipping, I call as a D, spray as called as the S, at least one of them here. How you can say that for the interaction is, this is mu 1D. What is the meaning of the 1D1? That is this element. That is the first primer, first dipping, first element. 1S1, that is the first primer, first here and this one. Now your target is to complete this one. What you can do is, you can firstly take the addition, you can find the total of this. You can find the total of this. How you can find the total? You can see, you can add all these 6 elements. You will get the 28.7. You can add this, you can add this, you can add this. Similarly, you can add this twice are there, and this is my grand total are there. Once you finding the total are there, then we will find the primer R. How many primers are there? What is the degree of freedom? How many primers are there? 3. So the degree of freedom is my 3 minus 1 is 2. How many methods are there? There are the 2 methods, dipping and spray. So degree of freedom is 2 minus 1 is 1. How you find the interaction is, you can simply take as the product of this. Here, 2 into 1 is 2. How you find the total? How many elements are there? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 elements are there. So the degree of freedom is 18 minus 1, 17. Now how you find this one is 2, this plus this plus this plus this is nothing but my 17. So this is my 2 plus 1 plus 2 plus this is must be my 17. So what is that? This is nothing but my 12. So you can find like this. Now how you find the sum of square all these elements? What you can do is you can firstly find these all form. These are a form, that is a summation of this. What is the C? C is the correction factor, as we discussed in the one way and the two way. That is a grand total 89.8 square. How many total elements are there? 18. What is the meaning of this is, that is the first element square, that is that this is the 4 square, plus second element is 4.5 square, plus next element is 4.3 square, plus next element is 5.4 square, and so on until you will get the last number as of 5 and 5 are. You can see this plus this up to 5 plus 5 and minus whatever the answer you got. After the calculation you will get as a 10.72 is here. Similarly, you can find the number sum of these squares by using here. What is the meaning of that? T, capital T is my total. Now you are talking about the primal. So this is my primal. What is the total of the first primal is 28.7. How many elements are there in this? 3 plus 3, that is a 6. Plus second number is 34.1 square. How many elements are there? That's a 6. Next one is 27. How many elements are there? Is 6 minus of C is there. This number is my 4.58. Similarly for the methods, method is total is my 40.2 square. How many elements are there in this column? I is 3 plus 3 plus 3, that is a 9. Next one is 49.6 square upon 9, and so on. You will get this number as 4.91. Now how you find the interaction factor? That's a very simple. That's a way of, again you will get this one minus of C minus whatever you obtained. So this number is we already obtained as a 4.58. This number we already obtained as a 4.91. This number we already obtained as a 89.8 square divided by 18. Now our target is to find this number. What is the meaning of that? So this is the interaction. So this interaction means this element. What is the total of these three elements? You can find the total of each of these pairs are there. Total of this is here. Total of this is this, this and so on. So what is the meaning of this factor is 12.8 square divided by how many numbers? 3 numbers. This is the meaning of this. 15.9 square. How many numbers are there? 3. This is the second number. Similarly 11.5 square and so on. All these 6 numbers are there. This is the value of the C. This is the value of the primal. This is here. After the calculation you will get as a 0.24. Now finally how you can compute this number? This plus this plus this plus of this is equal to this. So you can subtract this number from here. That is my 10.72 minus of sum of these element you will get here. Now once you will get this table, now the rest of the calculation is very simple. You can find this number as a 4.58 divided by the degree of freedom. 4.91 divided by its degree of freedom. 0.24 divided by its degree of freedom. 0.99 divided by its degree of freedom is 12. So after the calculation you will get these numbers are here. How you compute the F ratio? That is the first number is 2.29 divided by the error. Always divided by the error. Whatever the answer you will get here. How you compute this number is the 4.91 divided by the error. Similarly corresponding to this 0.12 divided by 0.8. So after the calculation you will get this results. Now once you will complete this ANOVA table, we will compute the degree of freedom. How you compute the F value? You can compute the F value like here. For this number, how you compute this number is 4.58 divided by the it's a 2.29 divided by 0.08. What is the degree of freedom of the 2.29? That is my 2. What is the degree of freedom of the 0.? That is a 2,12 here. Similarly for this, what is the degree of freedom is? This is my 1,12. This number is corresponding to this number is my again 2, so this value you can compute from the F table. How you can do that? Like this way. So if I want to find the critical value of F, say 3, 2 of 0.05. So first value is the numerator, that is a 3. This value is my 2. Level of significance is 5. So what is the value of this is 19.16. The same way we have computed the values at here. You can see 2,12, this is 2, and you can move down here. This is now 4 and so on. You can get the here. Now once you will get this value, now you can compare this value with the help of here. Whenever F ratio is greater than of the F critical value, we rejected H0. Otherwise, we accepted H0. Now you can see the degree of freedom corresponding to this is my 2,12. So the value of 2,12 is 3.86. The F ratio is greater than of this, so we can reject it H0. Same for here. What is the degree of freedom for this is 1,12. The value of this is 4.75. You can compare 61.38 is greater than of the 4.75. H0 is rejected. However, for this number 1.50, what is the degree of freedom corresponding to this is 2,12, which is 3.89, which is less than of the 3.89. So H0 may be accepted, or you can say we will fail to reject it H0. So H0 is rejected, so it means there is no interaction between the primer types and the methods. Look at the another example. Now you can move on quickly. So there are some factors are there. Now you can see in our previous example here how you can do that. You have to firstly take the total of this. You can find the total here. So but how you can find the SS of the total, that is 17 square plus 20 square plus 16 square and so on until you will get as of 29 square minus plus 31 square minus of C. You can see there is a lot of the calculations are there. In order to make them a calculation easier, you can make the calculation easier, you can subtract any number from here. Say I can subtract the 20 from the each observation. You can subtract as a 21 also. You can subtract 43 also. Even you can add 20 also. So you have to add or subtract the number which is nearest to your calculation. So once you will subtract this, how you can get a minus of 3? You can subtract 20 from each number. This number is my here. 20 minus 20 is 0. 16 minus 20 is my minus 4 and so on. Now you can see the calculation becomes easier. Now rest of the calculation are similar. You can find the total of these row wise. You can find the total of the column wise. Once you will get the total of this, you can see 15 and so on. How you can find the degree of freedom? How many temperatures are there? There are the 4 temperatures. Degree of freedom is my 3. How many copper contents are there? These are my 4. Degree of freedom is 4 minus 1, 3. Interaction is you can multiply them. 3 into 3 is 9. How many total elements are there? These are here, you can see these are the 4. This is a 2 plus 2 plus 4 and so on. So these are my 32 elements. So the degree of freedom is my 31. So you can easily find this number, this plus this and so on. You will get this number as 16. Now how you can find these numbers? You will get a C. What is the value of the C is there? The grand total is my 29 square. How many total elements are there? This is my 32. How you can find this number? Now you can see minus 3 square is a 9, is a 0. 4 square is 16 plus 1 plus 16 plus 4 plus so on up to the 9 square, that is 81 plus 121 minus of C square. After the calculation, whatever you get, you will write here as source of total. You will get here. How you find the temperature? You can see this is a 15. You can substitute here. There is a 15 square. How many elements are there in this? 8. Here minus 21 square, 8 and so on. Similarly for the column wise, this is a minus 36. How many elements are there? Again there are the 8 elements, and so on. You will get the answers as here. How you find the interactions? Now you will get the sum of these elements. You can get using this formula. You can get the total of this. What is the total of this is my, you can see what is the total of this is minus 3. What is the total of this is again minus 3. Now 6 square. How many elements are there? 2, and so on. Last number is my, this is my 5 square. Total 2 elements. Total is my 20. 2 elements minus C. This SS temperature we already compute. SS copper we already compute. After the calculation you will get this number. Now once you will get all this number, you can easily find this 113, or you can add them all and subtract from this. You will get the answer as here. How you find the mean of this? That is a 1 this divided by 3. You will get this number. Similarly this divided by here, this number divided by 9, 108.5 divided by 16, and so on. You will get these answers. How you find these numbers are there? How you get this number? This divided by error. Always remember that, divided by error. How you get this number? 232.6 divided by error. This divided by error. What is the degree of freedom corresponding to this is 3, comma error is my 16. Degree of freedom corresponding to this is 3, 16 again. Degree of freedom corresponding to this is my 9, 16. So we need the 3, 16 and 9, 16. You can get the table values are here. Now you can compare them. This value is again, if F ratio value is greater than of the critical value, then we can reject it H0. Otherwise we will accept it. So you can see 7.67 is greater than of this, so we can reject it. This number is greater than of 3.24. Again this number is my, here is 3.24. We can again reject it. And 1 point is 9, 16, that is my 2.54. This number is my less than of this, so H0 is accepted. So that is, there is no interaction between them. Look at the last examples are there. Now you can see here there are the 2 different shifts over here. So that's again a very simple. Again you can see some of the observations are there. You have to construct the table. You can subtract any of the numbers are here for the calculation easier. So let's say I can subtract the 8 from the each of this. That is a minus of 2. This number is my minus of 4. This is here. This is only for your demonstration. If you want to add them, you can add them. If you want to subtract minus 7, you can subtract minus 7. So I can combine these 2 tables into here. This one is for the first shift. This minus 3, that is a 5 minus 8. This is 7 minus 8. This is 4 minus 8. I can write like in the blue color. Similarly for the B, I can write this brown colors are here, and so on. Now rest of the part are similar. You can add them in the row wise. Now once you will add them row wise is minus 16. This is a minus 10, and so on. This is the grand total. How you find the degree of freedom? How many machines are there? There are the 4 machines. Degree of freedom is 3. How many shifts are there? 1, 2, 3, 4, 5. You can see there are the 5 weeks. So 5 minus 1 is 4. The interaction is my 3 into 4 is 12. What is the total number of the observations? How many totals are there? 5 in the each row. 1, 2, 3, 4, 5, 6, 7. So how many observations are there? That is my 5 plus 5, 10, 20, 30, 40. So this is my 39. You can easily find this number as of here. Now you can find the sum of the squares. You can easily get these answers as of minus 2 square, minus 4 square, minus 3 square, minus 3 square, this plus of this plus this, until you will get minus 1 square plus of 2 square minus of C. After the calculation you will get here. How you find this number is sum of the squares of the machine. Now these are the machine. So since now you can add them here. For the machine you can get as a minus 26. How many observations are there? Total 10. That's here. This is 5. How many observations are there? 10. These are my minus 17, and so on. You will get this number. How you can get the shift? What is the total is my minus 7. How many observations are there? That is a 8. You can get as minus 7, 8. Minus 13 square divided by 8, and so on. How you find the interaction is, now you can see there is a sum of this. What is the sum of this is? Minus 16. So you can easily find the interaction as minus 16 square, how many observations? 5. Minus of 10, how many observations? 5. 1 square, you can write as 1 square, how many observations? 5. Plus 4 square divided by 5, minus 6, 8 square, 5, and so on, until you will get as a minus 12 square, and so on. Minus of C, this the C. SS machine we already computed as a 51. 11.4 we already computed as here. We will get this 3.2. Once you will get, you can easily compute this value by getting, how you can get this number is 154 minus sum of these numbers. How you find this number is, that's a 51 divided by 3, 11.4 divided by 4, 3.2 divided by so on, and so on. You will get these numbers. Once you will get this, how you can compute this number is 17 divided by the error. 2.85 divided by error, you will get this answer. How you compute this number is 0.2667 divided by 4.24. This is the F ratio. Since in this question there is asked only about the ANOVA table, so that's here. But if you want to make the decision, then the degree of freedom corresponding to this is my 17, that is a 3, and error is 20, so 3,20. Here, what is the degree of freedom is my 4,20, and degree of freedom is my 12,20. You can take the values of this from the table and check whether it's a greater than of the critical value, then rejected, otherwise accepted. So this is the way you can consider about the 2 factorial experiment. In the next lecture, we will see how you can solve the 2 raised power k factorial design experiments. Till then, you can simply follow this link for finding the various videos. Best of luck, students. Happy learning.